Module 10, Section 1, Part D. In this short video, we will continue to discuss how to identify and mitigate damage from various pathogens. Starvation is a risk. It occurs, and I've had starvation in colonies that seemingly have a lot of honey. If your population is having a hard time staying warm or being insulated, that heat pocket, a bubble around them, can keep them from moving, especially if you have your population really starts to dwindle in the winter because of a viral or some sort of pathogen. You can have a small cluster of bees that survive the pathogen, but that aren't able then to access the food resources and starve. So common characteristic of starvation is bees head first in the cells. Dysentery looks a lot like nosema, and that's why it's important that you do your testing, whether it's a field test or whether you're sending samples to the lab. I strongly suggest the lab. It's cheap price to find out true diagnostics of where you're at. So for me, when I open up my hives and I see a strong, thriving colony that has defecate all over the face of the hive like this, I may not be as concerned, but I still would want to send a sample in to make sure that the defecate is indeed just them creeping on the side of the hive in the middle of winter to poop, and not because they do have a nosema load that they're currently managing. Varroa mites. So here is a video that I'm going to share with you. It's Dr. Jeff Harris from the Louisiana Bee Lab in the USDA. It's a little bit inaccurate about the life cycle of the varroa mite, but it's extremely valuable. And the reason it's inaccurate is a man named Dr. Samuel Ramsey published an article February of 2019 that proved that varroa mites, instead of eating the hemolymph or the blood of the bee, they actually feed on the protein or the liver tissue of the bee. And previous to Dr. Ramsey's publication on varroa mites, it was believed that varroa mites were phoretic when they cruised around the hive, which means they didn't damage their hosts when they weren't in the reproductive stage of larval development. So the belief was varroa mites only damaged bees in the brood nest, in the larva. Dr. Samuel Ramsey's research proved otherwise, that varroa mites were capable of taking liver meals or protein meals off of adult bees, which remedied a lot of concerns about the damage varroa mites do to bees and all of these symptoms that we're finding of mite damage, which is situations of like hormone imbalance, moisture retention by the bees on their external tissues, their exoskeletons, as well as their ability to live for a longer period of times. The idea was that most of the issues were the viral loads that were spread through the varroa mite activity, similar to Lyme's disease and ticks. But just recently, we found out much more through Dr. Samuel Ramsey's research about the true behavior of varroa mites. So you will be receiving this PDF that basically breaks down the life cycle of the varroa mite based off of our current knowledge and research of Dr. Samuel Ramsey. But the video previously mentioned is extremely important because it gives you an idea of the reproductive life cycle, not the meals they eat, don't worry about that, but the reproductive life cycle of varroa mites. Because if varroa mites are reproducing in the brood nest, it's important that we understand that so that as a beekeeper, you can manage your brood nest in a way to restrict the reproductive potential of varroa mites. And that's what integrated pest management can be about. Now, another mite that infects bees is called a tracheal mite. Now, these mites move into the tracheal tubes that run along the thorax and the abdomen of the bee. They're very, very small. This is a tracheal mite on a bee hair. And they take what we believe, now we're not sure based off of Dr. Samuel Ramsey's research, it's believed they take blood meals through the tracheal tubes, and which causes your bees to basically have emphysema. So symptoms of tracheal mite infection is a much shortened lifespan of your adult bees. You'll be seeing a difficulty at increasing your brood nest size. The good news about tracheal mites is most of the miticides that you're using to treat for varroa mites do kill tracheal mites. So you're seeing that miticide use for management of varroa mites does decrease tracheal mite risk. A nuisance and a friend, wax moths. So wax moths exist in nature, that they're meant to move into Abandoned beehives are old areas of comb that have not been used by active colonies, and the moths consume and chew through the wax, spin cocoons, as you can see these little silken cocoons, lay eggs, and then take off flying as little moths, tiny little paper moths. They're lovely because in nature what they end up doing is if there's a dead comb inside of a hollow of a tree or abandoned beehive, they consume that wax, creating that cavity's availability for more bees to come in and move in. They clean it up. As a beekeeper though, your biggest asset as a beekeeper is your wax equity. So what you're looking forward to having is you're going to want to make sure that you have protection against wax moths. So the number one way you can protect against wax moths is keeping your bee equipment stored in a cold space. So instead of storing it inside or in a heated garage, you're going to want to keep it in a cold area. The cold winters that we have in Canada tend to keep wax moth larvae at bay. Now, if you aren't able to keep your wax moth larvae at bay because maybe you're in one of those unusual locations then in Canada that doesn't get cold rather, or you're in an unusual location like you don't have a space outdoors to keep your wax moths at bay. When we talk about acetic acid treatment for the treatment of nosema in bee equipment, so basically vinegar, but 80% solution, that acetic acid treatment will kill wax moth larvae and eggs. So you're able to kind of keep your wax moth infection potential at bay. Mice. Mice are a really big challenge for outdoor wintering if you don't take them into consideration. The mice move into your hives not to eat the honey, not to eat the wax, but to stay away from predators and have an insulated space. And the mice will potentially inevitably just kill your bees because their activity in the hive, their defecate, their urination can really mess up the homeostasis of the colony and wipe out your bees. It's very important that you're considering mice so that you're able to guard against them, whether you have cats, whether you actually put physical entrance guards for mouse guards on your colonies to inhibit activity. But again, when I talked about winterization, avoiding using anything that's going to lure mice to your yard is a good choice. This is not a mouse guard, so that's an entrance reducer blocking the entrance. A beekeeper sent me this image and they said, yeah, I've got a mouse guard on. And I said, a mouse can move through a space the same diameter as its nose. So mice are unique where they can actually collapse some of their bone structures to be able to move through spaces. So if you're going to put a mouse guard up, it's important that you're using an actual approved mouse guard or screening that allows for bees to enter and exit that the mice cannot get through. An arbitrary little nail or screw in the place is not going to work sufficiently. So when you look at diseases and when you're looking at things going on in your hive, there's a lot of opportunities on how to cope. Everything from colloquial knowledge and education. There's a beekeeping book you can purchase now called ABC and XYZ of Beekeeping. It's from the AEI Root family, and it's a beautiful book. I strongly recommend owning it, and it's just an encyclopedia of knowledge. But the nice thing about that book is that every single year when they've done an amendment or an update to it, they've kept the original content and just added it. So you can see original feedback and recommendations on managing for disease circa 1920, pre-agricultural chemical use in beekeeping. So there's a lot of good advice in there, but there are products that are available that you can use. Particularly, Apivar is a synthetic pesticide that is used for the treatment of varroa mites. And so there are synthetic pesticides that are available there that do work quite efficiently currently, but immunity is taking place. So it's important that when we look at these diseases in the next section, that you understand that you're going to have to apply an integrated approach. Even though we've looked at all of these diseases and it can seem very overwhelming, the most important thing that I can recommend is that you just do your inspections, know your brood cycle, and be able to identify abnormality. You don't need to be an expert, but if you know what weird looks like, you'll be able to figure out what that weird is. If you have a mentor, great. Join a club if you don't. And if you do, be able to share conversations and open discourse and be able to hear good advice and sometimes bad advice from other beekeepers. Make sure you go to a conference. If there's a beekeeping conference near you, take the time off work if you can and go. If you're traveling, Figure out how to travel and meet a beekeeper while you're at it. Go through their hives. See if they'll open up their backyard to you. It's an opportunity for you to expose yourself to different managements, different pathogen issues in different climates, and different strategies of managing bees, which may open your eyes to strategies in which you can change your current management style. Remember why you got into beekeeping. You're doing this because it's fascinating, it's interesting, and you want to learn. So don't be intimidated by the pathogens that we just covered and the integrated pest management techniques and potentials that we're going to use in the next section. It's very important that you just recognize that these are barriers to success, but they are not inhibiting factors to your enjoyment. That concludes this section. Let's move on to the next.